Welcome everyone to another high performance enthusiast live stream here on our IT YouTube channel. In a previous video I often criticized BIOS vendors for all their bugs. A year ago ASUS, right, even bricked one 50x memory channel and all the surrounding bugs and stuff, and now Gigabyte with the Aorus Masters X670E, which ironically initially when I unboxed it, it worked okay, and then all the last 5 or so months BIOS updates only caused more regressions. Namely, my system was unstable. I had to reduce the Corsair and against DDR5 64 gigabyte 5600 MT significantly, right? And in the previous videos people always told me I don't know what I'm doing, although I'm computer scientist, 20-year Linux distribution, and grew up with freaking PCs. And I'm happy to report finally a positive video. The latest BIOS, you know me, I already didn't have much motivation. If it were not for the YouTube channels here, I would have already given up. I only by pure chance and accident I actually tried the latest BIOS. I'm now running F9C for a week, and I'm happy to report my previous video. Apparently Gigabyte was listening of all my input of like, hey, this is broken, it doesn't clock anymore, it's ridiculous. Finally, the performance is back, and I can report it is absolutely even more performance, right? I would accept shout out like, hey, it's actually freaking working again. It has now insane performance with this 5600 megahertz. So the regressions are fixed and it's more stable and more high performance than ever. It's in launch day, so it took you only 5 months of regression. They're finally here. So what I'm happy to report, so previously this memory here, so not a paid advertisement, just the stuff I got, and you don't really, so this is only 5600, and the reason I'm running that is because I'm compiling a Linux distribution and then I need freaking memory, right? Most gamers only run 16 or 32 gigs of memory, similar to Apple users, apparently enough, and that you get at 6000 over 6000 mega transfers. But if you go to larger sizes, 64, there are very few options, and 5600 is still, especially if you now go larger, the non-power of 2 non-binary size modules that are out there, when I checked yesterday, you usually only get them with 5600. And so previously, with the previous BIOS, I could never, let me just many keyboards in, because I need that in full if I find. So let's go through the BIOS, right? And also overclocking for dummies. So previously, what I'm running, you see here 5600, right? And I overclock this now. So this was never stable, right? I can now, with this BIOS, what I never thought is possible with this 5600, I run it now stable, knock on plywood, with 6000 freaking mega transfers for totally previously unseen, insane Linux compilation performance. And when you go through the, by the way, I should probably, if I wanna, let's save, I don't have a mouse. Do we have keyboard and mouse? 6000 enter, so that is freaking save it. Not that I screw my amazing performance. Of course, so the only, of course, for such overclocking you need voltage, right? They also moved the voltage now, but this here previously was in sub-menu. So naturally, this is rated 1.25 volt, right? So I obviously massively overvolt that. Don't try that at home. You might void your warranty. I have at times run it already with a little bit more voltage. I believe I have run this with 1.30 as well. But so obviously you need to overvolt that. And so previously, I can show you this previously, not even 3800 was stable, right? So with the launch day unboxing experience that I was satisfied with, the highest performance was massively the highest performance I got was massively tweaked 5600. So I had that previously, sub timings and even main timings significantly overclocked, I believe, to 34, 32, 54, whatever. And with the previous BIOS that I thought was pretty stable, like previously good old October BIOS, I never even got 5800 to be stable with memtest, or let alone compiling Linux kernel, right? So I'm totally shocked that now 6000 with this timing. So this is, mind you, this is sure this is not gaming performance, because we're not running 32 or God forbid 16 gigs of memory only. We are running a whopping 64 gigs of memory, and so this is still at a blazingly fast for this module's primary and sub timings. 36, 36, 36, 59. I believe so. This is still a massive overclock for this, as you see here, rated C40, as seen here, XMP1, 40, 40, 40, 77. So this is still 6,000 freaking mega transfers. And also here I tweaked most of this timings. Also, one is higher, so this RFC1, the built-in XMP and bandwidth and latency overclocking, posts that with some DDR training to 500 or whatever. So I increased that just for, the problem is I can't be sure which of those values cause instability. So if I lower some of those values, obviously memtest and Linux compilation will start to fail, right? So these are the timings. This is what all you can, also overall, right, I'm totally I have sample size 1, right? I only brought one freaking CPU because I'm not yet billionaire. And so this is sample size 1. I can run this now. I can't be sure what the BIOS programs here, because the previous BIOS was highly unstable, right? So whether this BIOS, this latest stable BIOS, really programs 8x precision boost overdrive scalar into the CPU or not, I can't be sure. But that's what I'm running this. Precision boost overdrive scalar 8x CPU clock override positive, boost clock 200, manual 99. This doesn't really change much. But also means it's a little bit silly, because I believe this. No, this is okay. This here, the PBO limits is anyway a little bit silly, because it always shows you can't put in there more than the motherboard and provides. A little bit negative curve optimize the internal GPU, and this is here is per core negative 20 on the first CCX and 24 on the second. I can also show you, so in comparison, the fastest that I used previously, obviously also voltage as overvoltage at that, and then you see here 46, yeah, auto, so that is 46 then, and yeah, 32, just probably kind of what I remembered, 32, 33, 55, which is obviously a massive overclock still for this rated 5600, and then basically all the subtimings a little bit lower even, as you see here, because it is 5600 versus 6000. And the other stuff obviously is similar to, that probably should be relatively, although even, yeah, even 4 times. So let's load the just saved 6000 profile. So what performance do you get with this crazy overclock? I have here Geekbench results for you, playing along at home. And I previously found my score of, so 26,000. So this is only comparing, the only thing is it's not that much faster, right? It's only, I mean, despite this 6,000 mega transfer overclock being stable so far for me, it's in reality, although the single core is lower, that is like thermal, the state of the moon and whatnot, right? So each time pre-warming, random BIOS training of whatnot, the feeling of the AMD CPU, you can't really give that much on this one random score. But it's reproducible, like 1% fastest, like sure, it's not that much, but if you compile each day software or even a whole week for 32 architectural variants, then each percent counts. So I'm surprised. So basically, you don't really need 6000 megatransfer memory, although the sweet spot and the best and so on, yes, it's 1% in this embarrassingly massive parallel workload. Although I'm totally surprised, yet thrilled and stuff that it's stable and works. And so also taking into account previously when I unboxed that, you can search for Linux results for this system. You will mostly find my results here on Geekbench. So when I unboxed that, I had like 24,000, then I tune and fiddle and stuff, and eventually I reached 25,000. A lot of the scores also, previous video, all the Linux kernel work, right? So it's not only hardware, the Linux kernel, MapleTree and generational last recently used improved the score, I think like 500 or stuff, quite significantly. The latest Linux kernel again has a little bit optimization. I believe the latest like 50 more score, 50, not much, but it turns out the AMD software implemented FTP or so is buggy and whatnot. So the latest Linux kernel disabled that for micro stuttering. So apparently with that micro stuttering, that might also have caused audio glitches here, my YouTube live streaming, which annoyed me already a lot, might have contributed another 50 or so scores here. And that performance, I can tell you, epic thread-ripping Linux kernel and your Linux distribution in 3 minutes something and 2 hours, whatever, with all the compiling through Rust, GCC, LVM Clang, Linux kernel, a whole freaking Linux distribution ISO in 2 hours is amazing. Previous video, right? 40% performance over RYZEN 5950X. It is just amazing. Last but not least, if you have watched through all the live stream, all the 13 minutes, that's amazing. Don't forget to share, like, and subscribe. And I can give you some more sense here, tips and tricks for overclocking for dummies. One quick check to the comments here. Roland runs multiple force PCIe 4 SSDs. Strip rate seems to replace run disk. And NES emulator runs quicker and stuff. So yeah, one last thing. So, or maybe I should actually make a dedicated video. If you wanted to overclock yourself, I just need to switch here my video inputs. This capture. So overclocking for dummies, right? How I do that here is a pro tip: only do one or some related values at once, right? Because if you change a lot of things, it might not post and or have instabilities, and you always need to go back. Was it that one? Was it that one? So obviously for overclocking the CPU, and again, overclocking and undervolting. So in my case, undervolting for better thermal headroom and higher boost. You also want to do one step at a time, and it influences the CPU undervolting, and performance boost optimization also influences your memory stability, right? So if you have faster memory, you might not be able to overclock your CPU as much because previously it was more idle and waiting some clocks for memory data to arrive in the cache and stuff, right? And so you might, if you want more memory clock or stuff, you might need to go back with PBO, performance boost optimization, for example. So for some memory overclock, of course, you first need to increase. All right, this is now they changed that. So you need to increase your memory voltage a little bit. I suggest to start in 0.1 volt increments. And also, don't blame me if you burn out your memory. I have not yet burned my memory. I'm basically running this. I'm running this overclock to 1.3 something volt. Actually, I'm running my memory. This course here, overvolted to 1.33 and 3.1 and 1.81 volt for 3 months already. Previously with 5,600 mega transfers, and then you first want to change the major timings. So also, by the way, in the meantime, I figured, so this low-level latency support and high bandwidth support, as far as I have seen, so when I unboxed that, and initially I thought that would just be some special parameters internally. But in the meantime, I figured this both values, this both options, influence the memory training. And so with this bandwidth and low latency, that is altering the algorithm here, producing different subtimings. So you should be able to see that. And I have this enabled, but you also be warned that they cause instability, right? So with these options enabled, my system was never stable and I had to dial back some of those low latency and bandwidth trained values. Then I suggest to first dial down, decrease those major timings, cache latency, TRCD, TRP, TRAS here, those primary timings. I was actually surprised how much I can go down there. As you've seen previously, this was at 5600. I reached 32, 33 and 52 or whatever that was. So that is quite massively. And of course, voltage helps, right? But in RYZEN, eventually you might destroy and burn out your memory. And then I also increased the subtimings. By the way, new, the latest. So previously the BIOSes didn't show TREF here. This T refresh specifies the average time between refresh requests. This was not an option, so this option is new with one of the latest BIOS updates. I have not yet quite determined or tried too much out how this influences performance. But then, of course, all those subtimings do not necessarily influence the memory bandwidth and latency much. So obviously you have one of those very high TRFC and stuff timings influence that more than the least important subtimings here. So basically, it's not necessarily that all of those influence that in priority sorted order, but I would still suggest to kinder start decreasing those here top to bottom. That makes most sense for the most part. And then for first or last, depending what is your priority, for CPU performance optimization, for me it was always the best to undervolt the CPU, because with more volt I have already 36 centimeters, so Kraken set 73 or so AIO water liquid cooling block here, and that can not keep this Ryzen 7950X cool, right? I probably need to invest into a custom water loop next. So for me, the best is to undervolt this. Maybe I can even undervolt more. I've not yet tried this. I also have the impression that the new BIOS is, or AGESA is more stable there, because previously I could not undervolt that much to still be stable. So for me, the best result, I like PBO, I like still energy efficiency, right? So I still like my cores clock down when idle, so I don't have a static all-core overclock. Starting with undervolting until it gets unstable, then dial it a little bit back. I probably still have not maxed that out necessarily. And then also try here the scaler. That is a little bit... this boost overdrive scaler apparently changes this built-in silicon health management, and as the help text says here, can potentially achieve higher sustained frequencies. I could still try if I can stress it out even more, right? If I would have too much time. Also, for me, max CPU boost 200 helps, but somehow you need to keep your CPU cool, right? For me, it starts to boost less when it reaches 100, when it reaches 90 degrees Celsius. So for me, even with this massive undervolt, it does not consistently boost 200 megahertz higher, right? Yes, still I allow that and it helps a little bit, but you need to cool this more. Then again, so this, by the way, both curve optimization and undervolting and this boost tweaks all depend on voltage, right? And temperature. So depending, and of course silicon lottery, but if you have one CPU, like I have here one CPU, so if you undervolt less, you can of course have a higher PBO curve optimization here, right? But the point for me is like, basically this is a curve and like one is a dynamic dynamic threshold of decreasing the voltage, right? And with that, the curve. So if you have less do you call this dynamic? Less voltage offset, like if you basically have the other main voltage here, yeah, dynamic, it's dynamic V-core. If you have that at 0, then in my experience, you can lower the PBO curve optimization more. But that is not my point, right? I want already the idle and like all like moving, my understanding, moving all of those voltage curves down first with this dynamic object. Dynamic object, too much stuff here. Dynamic voltage offset. And so I like to move that down first significantly, like 0.03 volt, maybe more, your mileage may vary. And then on top, do this PBO precision boost overdrive curve optimization on top of that. So without this dynamic offset, I might have even here 30 or whatever, but my point is the combination of that at idle and all the frequency range to the very highest PBO. And so again, it influences that, and if you decrease one, you might have to decrease the other, and that makes all of this tricky, right? Which is why I recommend to do one set of values at a time. I have not bothered to optimize that here per core. I only have here per core because I want that per CCX. And if I have a higher curve offset, I start to get spontaneous reboots and random segmentation faults, right? And the difficulty is I have not yet found out a system with too much memory overclock. I get two things, either random segmentation faults and certainly memtest 86 failures, but also spontaneous reboots, right? So I can never be sure, is a spontaneous reboot or segmentation fault, is that due to my CPU undervolting and overclocking or the memory, which is why I suggest change one thing at a time and don't change it too much. Also, it's super annoying, right? You change it too much, your system doesn't post anymore. You need to NVRAM reset. So save that at times more permanently to your profiles. And that is an annoying thing, right? You change stuff, it doesn't post. That's annoying. Huge minute-long NVRAM reset and DDR5 memory retraining, and otherwise spontaneous segmentation faults and stuff. And so also stability tested, right? It's not more annoying than you game your AAA game and you get spontaneous reboots and stuff. Test the heck out of it, which I of course do with an instantaneous Geekbench run and Linux compilation try. And for me, a full system validation is of course compiling all of, no, I need to check, all right, I have that here. For me, a full system stability validation is of course, does it compile all of T2, which takes 2 hours. So for me, at the end of all overclocking, does it blend or does it, so can we load our website? Does it compile? Just freaking amazing. T2 Linux, which takes 2 hours, which is of course, I do not do this for all subtiming, right? So first I get the general overclock and impression, and at the end of the day, if that is somewhat stable and it can compile Linux kernel, then 2 hours, have lunch or dinner, and then you can be relatively sure that your system is stable. And then at the end of the day, if your work really depends on it, let's say you are a Linux kernel developer, Chrome, Firefox, LibreOffice, or all the other fun stuff, Mesa and so on, and you really need a dependable system, and you really want to be on the safe side, last pro tip, dial back all of those values a tick. Yes, you lose performance, like let's say all of those, of course, just when I also, ideally a full screen here for me. Basically go in there, and if you want to be on the safe side, let's say make this 6x, 150, all those to like 18 there, 22 there or so, and all the memory subtimings. Like, of course, if you run like really important stuff like a space station or stuff, then obviously ECC memory and no overclock. But otherwise, also all the subtimings, right? Sure, you lose a little bit of performance, let's say, let's make this here 38, 37, 60, and so on. You probably get the idea. And sure, you lose a little bit of performance, but again, that might not be that much. Let's see, if you lose 1% of performance, that is nothing to compare to losing an hour or a whole afternoon of work, because you just in the middle of your work, you debugged something in the Linux kernel or QA, QEMU or whatever, and in the middle of that your system reboots. Or worse, you get SSD file system corruption because your system has written some random garbage, and you lose even more work and time of reinstalling your system from backup or whatever, and so on. So yeah, that is the last pro tip. I hope you enjoyed this and learned something. Oops, no, I, of course, wrong focus. I'm impressed that Gigabyte fixed this. I did not expect this, as per usual with the PC vendor #peakbugs and quality. I expected that never to change again. So I'm happy to stand corrected here. I'm happy that someone at Gigabyte listened to my feedback, or they found themselves that it was simply unstable, but people also at times didn't believe me. Anyway, that's the first video. I'm a very happy camper with this performance. This performance, as you can imagine, 26,536 here or whatever, 26,000 is certainly, sure, most people don't need this, right? Do you need this for gaming? No, most AAA gamings do not make use of this many threads, but for people who embarrassingly parallel compile software or run virtual machines and all the other surrounding high performance stuff, this kind of performance I could have never dreamt with. I could not be happier with compiling software, #peakbug, right? Compiling software faster to build errors was never that quick. And I hope you enjoyed this additional feedback. One last check on this. Apparently AMD did a really good job with Expo certification. So this stuff is not Expo, right? I mean, this is Expo's only certification, right? For the most part. And pre-stored values. So this is not Expo, right? And Intel XMP ready. It's, of course, I understand it's like a marketing certification. So yeah, so also can we focus somewhere? That's the idea. Intel XMP ready. So of course, that is not Intel AMD memory. That is just the stored profiles and validation testing. But yeah, it's and so the timings you will for Intel and Expo at the lunch day I brought this. There was not an Expo profile. Also, they don't change the PCB, right? So I would not expect an AMD Expo certified module to have different layout or whatever. In the meantime, exactly this exists as an Expo version, but I would be surprised if there's any other difference than the profile data stored in the SPD, EROM, EEPROM. And you don't really need that, right? So even with all the subtimings dialed in manually and stuff, and also, again, launch days, this was stable, right? So it was just the last 5 months of BIOS updates were simply unstable and unusable. Whatever bugs of programming the wrong values, of maybe the AGESA, of course, as this stuff is closed, without years of reverse engineering, I wouldn't even know what was wrong in those previous versions. I can only tell you, it was so unstable. It was not possible to use in any serious form. So yeah, and again, so what previously was stable, even with conservative values, timings, wasn't stable anymore, right? So it was not just Expo versus XMP, which again is only the predefined profile values there, as far as I understand. And yeah, that was clearly buggy, and it was, last but not least, too long didn't watch. Finally, with the latest BIOS, it is more stable and more high performance. than ever before. So I'm running F9C now, as seen here, right? Gigabyte X670E F9C. I've rebooted this already a gazillion times, 20, 30, 40, 50 times rebooted in the meantime. Happy to report it is rock solid. The only thing I've not yet tested, IOMMU is buggy with Linux. So when I booted the previous BIOSes with IOMMU enabled, Linux would not be able to use, for example, the NVMe, SSD and stuff. I have not checked. That is, of course, why I also would wanted to use a new BIOS, right? Because eventually I would have hoped they fix IOMMU implementation details for Linux, for example. I have not yet had time to check whether IOMMU compatibility with Linux improved the stuff, but at least performance is now more amazing than ever. And again, last but not least, 6,000 freaking mega transfers. I would have never expected, dreamed, demanded, expected to be running here with this platform and memory modules. That's it for this video. I have more stuff coming, right? I will also, more software, hardware. I don't want to tease too much. Don't forget to share, like, and subscribe. We are not yet done with this hardware and this performance and this memory. So don't forget to share, like, and subscribe for more AM5, DDR5 memory stuff to come. That's it for this video. I hope you enjoyed this and learned something. Don't forget to share, like, and subscribe. Patreon, GoFundMe, GitHub, sponsorship, YouTube membership, all the other good stuff. I hope you have a good day and night. Happy overclocking. Don't burn your hardware. And I hope to see you soon for the next videos and fun live streams to come.